Hello guys, and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to take the subnetting process that we learned in the previous video, then let's start to apply this and go through examples so you guys can really understand this subnetting process and really understand to see how it works. So, subnetting example 1. Okay, company X, they want to create subnets using a Class C network. Okay, this is going to be a pretty easy one to start off with. They need 23 subnets with 25 hosts per subnet. And key point over here, they want to waste as few addresses as possible. Now, when Cisco lists this in questions, what they're really saying is, okay, you may have some bits left over for when you calculate how many subnet bits you need and how many host bits you need. Well, what we really want you to do is we want you to use the smallest size subnet possible in terms of for number of hosts, and still meet the requirement. So what that means is those extra bits are going to be subnet bits. Now, this may be the case in this example, this may not, but what I want you guys to do, I want you to pause this video. Yeah, that's right, pause the video and go through this example yourself. You know, you may have taken notes in the previous video, so just go through those notes, go through the subnetting process without me at first and see what you get. And then I want you to play the video and then we'll go through it. So guess what? Pause the video now. So, I'm assuming that you've paused that video and that you've gone through it yourself, and that if you're watching now, then you've already done this subnetting example. So let's go through this. So, going through our process, okay, and as a spoiler alert, I will show you how to speed this process up, but just for now, we need to understand truly and properly what we're doing, okay? So, the first thing we're going to do, we're going to now convert this IP address with this class for network and subnet mask into the binary equivalent. So to do that, let's list out 192 in its binary equivalent. So I think that's going to be, yeah, it's going to be, so 1 1 0 0 0, how much is that? 1 2 3 4 5, yeah, 6 7 8. That's the first octet. Okay, 168. Okay, that's so 128. That leaves me with 40. So we don't need to 0 here. So 32, 16, 8, 4, 2, 1. So let me just calculate that again. So 128, that gives me 168, 20, 48. Okay, yeah, that's correct. So that second octet is going to be 1 0 1 0 1 0 0 0. And I know what you're thinking, guys. Why do we have to translate the class for network, the IP address, into binary? And again, this is just so that you know what you're doing and so that you can help visualize it. Okay, so obviously 1, that's going to be pretty easy actually. That's going to be 0 0 3 4 5 6 7 8, and obviously your zeros. Okay, blah blah blah, that's going to be your zeros. 4 5 6 7 8. Okay, brilliant. Now let's list out our subnet masks. So 24, that's going to be 24 binary ones, or in this case, in decimal, 255.255.255.0. Now, in the exam, they may list, okay, in subnet, in prefix format. Okay, so if they list it in decimal format and you have to convert it into prefix format, again, that's a pretty simple way, because obviously you know, okay, I know that if there's a 255 in the octet, guess what, that's going to be 8 binary ones, so I don't need to write that out. And then you can just focus then in on the octet, which is neither a 0 or a 255. And spoiler alert, that's how we're going to make our subnetting process quicker. But more about that later on. So 1 2 3 4 5 6 7 8. Okay, so dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So obviously at the moment the first 3 octets represent our network, last octet represents our host. So the idea is now, okay, we need to have 3 subnets with 25 hosts per subnet. So now all we need to do is calculate how many bits we're going to need to take to meet the subnet requirement and how many host bits we still need left. Okay, so 2 to the power of 1 is 2. 2 to the power of 2 is 4. So I need to have 2 subnet bits. Now that leaves me with 6 host bits. Does that allow me for the 25 hosts per subnet? So again, we go through 2 to the power of 1 is 2. 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6, that's going to be 64. So let me just make sure I calculate that right. So we got 2, yeah, with 6. Okay, yeah, so that makes sense. So 2 to the power of 1, 2, 3, 4, 5, 6. Okay, so we got 6 host bits left. Well, guess what? You can see here, this is why I mentioned this in the first place, where's as few addresses as possible. So even though we've got 6 bits left for our hosts, we're actually going to use that extra bit for our subnet, and the reason being is because we've been instructed to waste as few addresses as possible per subnet. So now I'm going to take 3 bits to be my subnet, and that leaves me with 5 bits to be the host part of my IP address. That gives me 32 hosts. Essentially, that gives me 30 hosts. So remember, 2 to the power of, let's say, 5 minus 2. So 2 to the power of 5 is 32. 32 minus 2 is 30. So that gives me 30 IP addresses per subnet. Now, I need to find my increment. All I do is I look, okay, in my subnet mask, where is the last binary one? Well, the last binary one just happens to be in this false octet again. So guess what I'm going to do? I'm going to now write out this binary number in my chart. So you will always be using this chart. This is a good thing about binary, because you know what chart you're going to be using. You know that, okay, in the beginning of the exam or when I'm going to subnet, I just need to memorize this chart. 8, 4, 2, 1. Okay, so now to find my increment, all I do is go down here. Where the last binary one is, that is going to be my increment. So the last binary one comes under 32 in my chart. So 32 is going to be my increment to find my subnets. So now let's go through this now. Let's start listing out all of my subnets. In this case, I'm going to use, I don't think I've actually got text here. Okay, no, don't. Okay, so I'm going to have to just use the drawing pen. So please mind my drawing, it is pretty terrible. So let's start listing our subnets. So 192, and obviously I would have converted my subnet mask back into its decimal equivalent. So in any case, it's going to be /27, and obviously we still got the same IP address. So 192.168.1.0.24. Okay, so just imagine that that's 24. So now let me start listing out my subnets. So 192.168.1.0/27. Okay, add 32 to the last octet. That gives me 192. So obviously I know my increment is going to be my 4th octet, and then this tells me how much to increment by to find my next subnet. 192.168.1. And just as example, so let's say I wanted to find this /27, okay, in its decimal format. I know, okay, /27, that's going to be 27 binary ones. I know that there's 8 binary ones per subnet mask octet, so that means the first octet is going to be 255, okay. Second octet is going to be 255. Third octet is going to be 255 as well. That means my last octet is going to have 3 binary ones. I input 3 binary ones into my chart, followed by 5 binary zeros. So 128 plus 64, that's going to be 192 plus 32. That's going to be, so 224. So that's my subnet mask in binary. 255.255.255.224. So as you can see, we can use all these shortcuts because we know that, okay, our subnet mask is going to be 4 octets of 8 binary ones, of 8 binary bits, and we can just calculate it like that. So that gives me 32/27. This gives me over here 192.168.1.64, and you get the idea, okay? And again, because the subnet mask is only going to be because the subnet part is only going to be in my 4th octet, it means I can only increment in this octet. Now, this is why I obviously drew out the IP address and then the subnet mask in binary first, because in binary we can only change the subnet part of the IP address. So that means that because the subnet part of the IP address only relies in the 4th octet, it means once I get to, let's say, the last subnet mask, then imagine that's going to be, so again, so let's look at 256, so 256 take away 32, that gives me 224 actually, so that's going to be my last subnet. Once I increment by 32, and that gives me 256, well, guess what? I can't increment by 1 in the next octet because that represents my network. That's why it's so important that when you're learning, you have to break it down into the 3 parts, because we can only change what's in the IP address based on which bits of the IP address represent our subnet part of our address. Any bits which represent the network part. So again, the first 3 octets represent our network part. I can't change those because the first 3 bits of the 4th octet represent our subnet part of our IP address. I can change those. And again, just to work out the range of addresses, I add 1 to my subnet ID and I minus 2 from the next subnet ID. So in this case, this would be .1 through .30, and this one would be, let's say, .33 through .62. This one's going to be .65 through okay, so 32 is going to be 96, 94. So yeah, so that's our subnetting example 1 complete. And as you can see, I've expanded on a few ideas which we discussed previously. I've also added in some new ideas as well. And that's why I thought it was important that when you're learning, you have to break the IP address and subnet mask into binary, because you have to see, okay, I'm only going to be changing the subnet bits, or the bits of my IP address which represent my subnet. And so as you can see in this case, so in the previous example, how we incremented by 1 in the 3rd octet, and the reason being is because that 3rd octet, the entire of the 3rd octet represented our subnet part of our IP address. However, in this case, the first 3 octets represent our network part. They're never going to change. We're only going to change the 4th octet to represent our subnet. Okay guys, so that's our first subnet example covered. Join me next time where we'll go through our second subnet example. Again, if you have enjoyed this video and would like to see more content like this, then please subscribe to my channel, and thank you very much for watching.